Okay, so today we're going to be looking at section 6.3, and in this lesson we're going to continue to look at the graphs of quadratic functions. Remember, the graphs are called parabolas. So if they talk about a parabola, they're talking about the graph of a quadratic function. We want to be able to look at the graph and in any of the equation in any form, okay, to identify the key features, which are the main ones are the vertex, the y-intercept, the x-intercept if you can find it. We haven't really got everything in place yet to be able to find all x-intercepts at all times. But if you can find them, you want to make sure you identify those. We have an axis of symmetry. These are all things that we want to be able to do. And in addition to that work today, we're going to learn how to write quadratic functions from certain data. Okay? So let's take a look at some things here I have. And I'm leaving it out here so you can see it so that you can, for those who want to, this is a recap of things that we've already done. We talked about this last time. Oops, excuse me. So let's go ahead and take a look at this. And how do I find the key features of quadratic graphs or parabolas? Okay. How do I find the vertex if I'm in vertex form? So this is vertex form right here. So what we do is we take the stuff in the parentheses, we set it equal to 0, we solve for x, and that gives me the h. And the reason why you want to do this is get used to this habit is because this also helps me do other things associated with graphing functions that are in this is what I call transformational form. Okay, so once I have the h, that's what goes there. Whatever k is right here, plus or minus, that's what goes here. If I'm in the standard form or general form, in this fashion right here, you're trying to identify the a, the b, and the c. These are the coefficients of each individual term in this format. The vertex is found by finding the x-coordinate of the vertex by using this little formula right here, negative b over 2a. Once you have that number, you plug it back into the equation, and you find the y value that goes with it. And that is your vertex. If I'm in factored form or intercept form, then P and Q, okay, the average of those two things, because those are x-intercepts, the average of those two things, so add them together, divide by 2, that would be the x-coordinate of the vertex, and plug that number back in to get the y value for it. Now, just like this one over here, where I take the stuff in the parentheses and set it equal to 0, to find that number that goes there so that you don't get the wrong sign, the same thing occurs over here. Okay, you want x minus p equal to 0. That's how you get the right p value. And then x minus q equals 0. Solve for that, and you'll get p and q that way, and making sure that you have the correct sign. That is the most common mistake people make in this process, is they choose the wrong sign for p and q. The axis of symmetry is basically x equals, it's an equation of a vertical line, so it's x equals, and then whatever the x-coordinate of the vertex is. So you have to find the vertex first. The y-intercept, I mean, you can find quicker ways like this over here. The y-intercept is whatever c is, that's the y-intercept in this one. But the other ones are a little bit more involved, so you can find all of them with the same technique, which is simply plug in 0 for x. You plug in 0 for x, you solve for the y value, and that is your y-intercept. Okay? So that's how you do those. The x-intercepts, except for in this form over here, these are the x-intercepts. Okay, so this is what this is the intercept form. To find the x-intercepts in these forms over here can require a little bit more effort, and you may not be able to find them all the time. So for now, until I teach you how to find the x-intercepts in those two forms, this form right here, the only technique you have that works here would be factoring to put it into factored form, and then you can pull the x-intercepts out. But sometimes you can't factor these. And so how do I find the x-intercepts? That's a lesson later on. For now, you can try and estimate it with your graph or a table to find an estimate, or you can also use a calculator to help you find the intercepts. And if you need that, there should be a video in your important information that talks about how to find the zeros on a calculator. I'll also show you in class. So that's what we did last time. We talked about all this kind of stuff. You graphed these things out and found this information. Okay? So what are we doing today? How do I change between quadratic forms? If I give you a vertex form, how do I write it into standard form and or factored form? How do I go about that process? And so that's kind of what I'm going to show you right now. It's one of the things I want you to be able to do in 6.3. I've kind of laid this out for you over here. I'll let you pause the video if you want to write that down if you want. I kind of showed you how to go to each one and what to do in each case. To go from a vertex to standard, you basically multiply everything out and then combine like terms. To go to vertex to factored, okay, right now you may not be able to do this, may not be possible at this time, okay? This is the tricky one. It may not be possible at this time to get into factored form. If it is possible, put it into standard form first, do this first, and then factor it. So that's the only technique you have, is to go through the standard form and then factor. How do I go from standard to vertex form? Find the vertex, and then plug the numbers in. So you have the leading coefficient from standard form. Remember, this is the leading coefficient. This A is not a fluke. It's this A. They all represent the exact same number. So if I'm in standard form, I know the leading coefficient is A. Whatever number is there is the number that's going to go there. And the number that's going to go there. Okay? So you find the vertex, take the leading coefficient, and then simply plug it into that format right there. Standard to factored form, just basically factor it completely, if it is possible. Again, may not be possible at this time. How do we go from factored to vertex form? Well, the same process as this one was. You find the vertex, you pull out the leading coefficient, which will be sitting right there, and you plug it right into that formula. Factored form to standard form, you just multiply it all out and combine like terms. So these are some things we're going to be doing here. I'm going to do some examples that illustrate this. And so here we go. So here is an example I want to do. I'm going to give it to you in this format. Our first one is 2 times x plus 1 squared plus 4. Okay, so clearly I have it into vertex form, and I'm going to put it into standard form. So this is vertex. We're going to go to standard form. And so what did I say we do? We need to multiply it out. So here's what it would look like on your paper. This is 2 times x plus 1 times x plus 1, because that's the squared part, plus 4. Now, you're going to multiply that together. Because I still have to multiply to the 2, I recommend that you wait, multiply that out, x plus 1. So that's the product. There's the plus 4. You can combine like terms in there. And now I have x squared plus 2x plus 1. Distribute the 2, 2x squared, 4x plus 2 plus 4. Combine like terms, and you get your standard form of that. So that's how I go from vertex form to standard form. Okay? It is very challenging to go to factored form at this point. But if you did, you would have to factor this thing right here. And I believe this one right here is not able to be factored at this time. Now watch, I'll show you. If I find a common factor, which is 2, and then you have 2x plus 3, I need to find factors of 3 that will add and give me a 2, and that just doesn't happen. So we are unable to factor this more to be able to find the x-intercepts at this time. I will show you how to do this at a later date. So this one we cannot factor anymore, so we cannot put it into factored form. Okay, it happens, but as we go along, we'll be able to remedy that problem in a little while. Here's another example. I'm going to give you this one. Here's this plus 2x plus 5. And let's put this one into vertex form. So we're going to go from standard form to vertex form. So what do I need to do this one? Well, I need to find the vertex. So the vertex follows the formula negative b over 2a. I recommend highly that you plug it in using parentheses first, then plug the numbers in. B is 2, so A is negative 3, B is 2, C is 5. You want to get good at identifying these values. So it's a negative B over 2A. And so when we reduce this down, and always make sure it's reduced down, negative divided by negative is positive, the 2's reduce out, and I'm left with 1 over 3. So the x-coordinate of my vertex is 1 over 3. I got to find the full vertex, so now I have to take that number and plug it into there. So we get a negative 3, 1/3 squared, 2, 1/3 plus 5, and we need to work this out. Okay? So this is 1/9 times 3, or negative 3, okay? Gives me a negative 1/3. 2 times 1/3 gives me plus 2/3 plus 5. And I'm going to take the 5 and I'm going to change it into a fraction also with a 3 on the bottom. So that becomes 15 over 3. I'm anticipating the addition of fractions. You do not want to use decimals. You need to give me exact values in this. So a negative 1/3 plus 2/3 is 1/3. 1/3 plus 15/3 is 16/3. So this is my vertex, 1/3, 16/3, and there's that. That's the vertex. The leading coefficient is negative 3. That's my A. So in my formula, I'm going to have y equals A, x minus h plus k. If k was negative, then I would put a minus sign here. But it's not, so here we go. So that is my vertex form of that right there. Can we do factored form on this one? Well, to do factored form, we need to factor that. Can I take y equals negative 3x squared plus 2x plus 5 and factor it? No. GCF, if this is negative, we bring out a negative sign. 3x squared minus 2x minus 5. And if I can factor it, then I'm going to have factors of 3. And I need to subtract and get a 2. So I don't want them together apart, so we want them right here. So the 5 will go here and the 1 here. So that gives me 3. That gives me 5. And if I subtract those in this fashion, I get negative 2. Positive 3x, negative 5, 2x. And so we have just found the factored form. Okay? Now, but I thought they were supposed to have the leading coefficient of 3 out here. And the answer to that is yes, we should. And it's sitting right there. There's that 3. Okay? If you remember factored form, it's supposed to have only an x here, not a 3. So I will accept that in factored form, but the actual factored form would be, I need to factor the 3 out here. In other words, divide out of 3. There's the negative 3, the leading coefficient. Okay? That will be an x. Divide 3 by that. Divide 3 by that. And then this one just stays the same. So there it is. Factored form right there. So that's how that can work. Okay? I think I have another one over here. If I give you this, I have negative 2 times x plus 1, x minus 5. To put it in standard form, so standard form, we just need to multiply everything out. And again, I recommend that you do the constant last. Multiply those two things together first, so I get x squared minus 5x plus x minus 5. And then multiply by the negative 2 throughout and combining these like terms. So this right here is going to be minus 4. So let me just go ahead and write that so you can see it. To be x squared minus 4x minus 5. And then times everything by negative 2. And this will be plus 8x and plus 10. Factored standard form. Can I go to vertex form? Yes, I can. Can I go from here to a vertex form? Well, to go to vertex form, okay, to go to vertex form, I need the vertex. So what is the number that makes that 0? So x plus 1 equals 0, so x equals negative 1. X minus 5 equals 0, so x equals 5. So there's P and there's Q. So my vertex is going to be P plus Q divided by 2. So I'm going to get a negative 1 plus 5 divided by 2, which is 4 divided by 2, which is 2. So once you have that, take that number and plug it in. So I'm going to have a negative 2 times 2 plus 1 times 2 minus 5. And when I work that out, it's a negative 2 times a 3 times a negative 3, and that is a positive 18. So my vertex is the point 2, 18. That's the vertex. The leading coefficient is negative 2, because it's in the right format. So that's the A, H, and K. So y equals negative 2, x minus 2 plus 18. And there it is. So these are some things you're going to be asked to do. Okay. In addition to that, I'm going to ask you to write equations, okay, from information. All right. So let me show you a couple examples I have from that one. Very quickly one. So, oops. How to write quadratic equation given. Okay. So if I am given a vertex and a point, okay, I can write the equation, a quadratic equation from it. Now, this can be given to you in a table format. This can be given to you in a graph. For example, if I give you a graph, and this is how I illustrated this one. If I give you a graph of a parabola, and I'm just kind of drawing a quick sketch here. Here's the vertex, and I give it to you as a picture as negative 1, 3, and then another point over here, which I'm going to call 1, negative 5, even though it's not drawn to scale. I gave you a vertex and a point. I could also have given it to you in a table and said the vertex is at negative 1, 3, and we have another point 1, negative 5. Okay, as long as you know that's the vertex, you can do that. You got to make sure you know that you got to have a vertex. If you don't have a vertex, then you need 3 points, and that's a little bit more complicated, which I will not do here. So you want to have a vertex and a point, then I can do this equation. So with that, the vertex we're going to use. If I give you a vertex, you're going to use the vertex form. Because I gave you the vertex, I gave you H and K. So this point is designed to give you A. This point is the X and a Y. It is a point on the curve, so it represents an X and a Y. This point also represents an X and a Y. It's just more important because it's the vertex. So to find A, which is what you need to find from this information, then you plug in these numbers in for all the letters except for A. So Y would be negative 5. A, X is a 1, minus, H is a negative 1, and then K is 3. And then we work and solve this for A. Negative 5, A, this is a 2, squared, that's 4. Okay, we need to solve for a, so we're going to subtract the 3, gives me -8 is 4a, and so a equals -2. Taking our information and plugging it into this formula right here gives me the equation of that parabola, y equals -2, x minus a -1 squared plus 3. And so that is the equation for that right there. Okay? What if I give you the x-intercepts? Now, there's sometimes certain books and maybe Delta Math or something like that might call x-intercepts. They might call them the roots. Okay? That's another name for x-intercepts. It's called the roots. If they say the roots, they mean the x-intercepts. Okay? They may also use the term zeros. If they use the term zeros, that also means the x-intercepts. So if I give you the x-intercepts and a point, again, that extra point is to help you find the a number, the a value in your formulas. X-intercepts means I'm going to use the factored form because that's the intercept form. X minus p, x minus q. Okay, so I need to find, and they give it to you. So here's how I gave it to you. This time I give it to you in a table. I give you x and y, and I tell you that we have a -3 is 0, -1 is -2, and 2 is 0. Okay, so I gave you those points right there. This right here shows you that those are the zeros or the x-intercepts. Okay, so that means that is P and that is Q. And I use that point right there, that XY point, to find the A. So let's go plug all these things in and find A. Y is -2. I don't know A. X is -1 minus P, and then a -1 minus Q. So we work these out. A, that parenthesis is going to be -1 plus 3, so that's a 2. A -1 minus 2, that's a -3. Okay? So that's a -6a equals -2 divided by -6. And so a is going to be a 1/3. Okay? So that means I can now take this number for a, these numbers for p and q, plug them into that formula, and I get 1/3 x minus a -3 times x minus 2. And there you go. Okay? So this is what you're going to have to do in your homework and stuff. So make sure you write down these notes, and we'll talk to you in class.